My name is Vadim, and today I would like to introduce my project. It is an electricity smart meter. Before we start, I would like to represent understanding of the problem. So many of us have an electricity meter, and usually it is outside of the house or it's somewhere in your apartment, but it's not really easy to see how many electricity you use. And most of all, you're not allowed to see all of that data online. And of course, you can't move it to your smart home if you have one. The possible solution is additional communicative module. In this case, your electricity meters should have the special connector like here. So another optical interface. Many meters has an optical interface like this one on the picture. And in this case, you can connect using the special hardware, but it's not that easy, even if you build it by yourself or if you bought it, because you have to implement even software how to communicate. Another one, LED meter constant. That is the special LED bulb that blinks m times per some period of time. And another, read directly from your home circuit. So if you have special device, you can connect to your home circuit. It also could read data from your inside circuit. And the another possible way, change your electricity meter to the new one. In my case, I believe the best solution is use LED constant. And why it is? Because almost every single electricity meter has LED constant. As I mentioned before, it is a special lamp that blinks every n time each watt hour. Even if you have very old electricity meter, it might have it. If we would like to use that way, the possible challenges we may have are when LED blinks, I mean, how often every n watt hour or kilowatt hour it blinks, how LED blinks, how long one blink is, what type of radiation, I mean, light does LED have, how to detect these LED blinks, how to convert LED blinks to human read data, how to send this data to your server, or how to just hold this, how to receive data on the server, how to read data on the server again, and how to use data, and more and more. And to be honest, each of these challenge contains more challenges inside. What we're gonna use in this case as a smart computer and or microcontroller, in this case is gonna be ESP32. And if we would like to register light, we need some special element, photo element. In my case, it's going to be phototransistor. Also, to set sensitivity, we need photoresistors or just a normal resistors. I will use resistors. Of course, we need wires and also USB connectors. And here you can see how we can connect our hardware. For this video, I have a special presentation stand where you can see the ESP32 as a microcontroller, and we have the photo element. In this case, it is a phototransistor. This phototransistor can catch the visible light and some part of the infrared light, but it can't catch the UV light. We need it because the LED on our electricity meter has an visible light, so this phototransistor allows us to catch that. And if we're talking about the sensitivity and correct work, so the possible way we always could have the signal as a zero from this phototransistor, and in this case the ESP32 always will have zero, of course, and could be an opposite side when we always gonna have the high signal. It means 1 from this phototransistor. To fix this issue, we must set sensitivity for the phototransistor, and for this we're using 2 resistors. In this case, it is the 10 kilo ohm resistor and the 5 kilo ohm resistor. Together we have 15 kilo ohms. Once again, how it works. First of all, we have an electricity meter and LED lamp that blinks n time per each watt hour. Then we have phototransistor that register that blinks. And then we catch the signal using ESP32, low and high signal from the phototransistor. And then we do some magic using software and send this data to Home Assistant, for example, or any other type of your smart home. Regarding to the software, the project split it for a few independent modules. The first module is Read Data Source module. It allows us to get data from the phototransistors, photoresistors, infrared receiver, and more. Another independent module it is Connector module. We always can use Wi-Fi or Bluetooth or Zigbee or any other wireless or wire technology. And then, sure, we have to send data some way. For this, we may use MQTT or HTTP or any other technology. This architecture ensures scalability and adaptivity, making it suitable for evolving needs and new technologies. By isolating functionalities into models, I can improve or expand any part of the system without risking disrupting elsewhere. Here you may see how it works. Every single blink from this LED we register using our phototransistor. And then we have a high signal goes to the ESP32 and then we manage that and send to our server. On the right side, you can see the ESP8266. It makes only fake signals for our system. As a smart home, I'm using Home Assistant. And to check our functionality, we should go to the MQTT add-on, press configure, and subscribe to the topic. And as we see for the last minute, we got 18. 18, it means we got 18 watt for the last minute. And we also may go up to the overview, and here I have some small chart that could show us what and how we use. Today is 27th of December. Let's choose the time since the 14 o'clock, for example. And here is the detailed chart about the electricity usage. Of course, if you would like to see all of that beautiful charts, you have to do additional jobs, but it is out of our project. But here you may see the some part of my implementation for the smart home and exactly for the MQTT connection and MQTT charts. In conclusion, I believe my project is a great example of a real life solution. It's not just about software development or computer networks. It also combines modern IT technologies, protocols, and practical knowledge of physics and electronics. This project was built entirely from scratch without using any ready-made electronics readers. Even a simple phototransistor setup required understanding Ohm law, how to use resistors, the concept of current resistance, and how a transistor works and can be applied. On top of that, I have to figure out how to convert an analog signal into a digital one for processing. I'm proud of this project because it is not only useful but also makes life easier by automating tasks and being flexible for future upgrades. Thank you for your attention.